Okay, this session is about terminology that we're going to use and some important variables that we will need as we calculate our sample size and our confidence intervals. First thing we want to look at is the z-value. Now in statistics there's what's called the standard normal curve. We're not going to worry about that in this class. You'll learn about that in statistics, or you have learned about that in statistics, but we're going to use the values that we find in the standard normal curve. When we do a problem, when we do a confidence interval or we do a sample size, we're going to talk about how confident we want to be in the data. And we're going to say we want to be 68% confident, we want to be 90% confident, 95% confident, or 99% confident. When we say that, that gives us a number to use in our calculation. We don't use these numbers, we use these numbers. If we say we want to be 95% confident in the confidence interval that we developed or in the sample size, if we're looking at 95%, we're looking at a z-value of 1.96. If we're looking at 90%, we're looking at a z-value of 1.65. These numbers you will use in the calculations in the formula that I'll show you in the next lecture. But right now, suffice it to say that we need to know these and their connection to these. So these two sets of numbers are very, very important because they have a large part to play in the calculations that we do. There's some other terms that we need to talk about, and those are right here, these terms here. When we're dealing with a population, we always are dealing with parameters. And usually, we don't know the value of the parameter. We can assume that we know what it is, and we do sampling to find out if we're close. But what we have is when we deal with a population, we have certain things that we're looking at. If we're looking at the mean of the population, we're using a term called mu, M-U. That's mu. It's the Greek letter. When we see Greek, we mean we're dealing with a population. That's the real value of the mean. A lot of times we don't know that, so we have a point estimate. And we have X bar here. That's the mean of the sample. If we're looking at the standard deviation in the population, we're dealing with the letter sigma. That's the standard deviation, sigma. In Greek, we see that, and we're dealing with the population. Very seldom do we know that. What we have is a point estimate for that called S, the standard deviation of the sample. If we're looking at a population proportion, it's pi. We have pi is the population proportion. Seldom do we know that. We have a sample proportion, and that's the small letter p. And then not parameters, but just to help us keep things straight, when we're dealing with the population size, we deal with the capital letter N. We're dealing with sample size, we're dealing with the small letter n. So these are some very important things to remember as we proceed through our calculations in the next next four lectures. We have point estimates come from samples, X bar, S, P, and N. Sample mean, sample standard deviation, sample proportion, sample size. Population parameters of the Greek letters, typically we have mu, which is the population mean. We have sigma, which is the population standard deviation. We have pi, which is the population proportion. And then we have n, which is the size of the population. We go back over here. We have our confidence levels on this side, and these are what will show up in problems. We want to be 68% sure that we're going to find the right value. We want to be 90% sure, 95%, 99%. And these are the associated z values. Now you want to remember how these are connected. Okay?